There were a couple of questions regarding fatigue parameters for the main SPA. You have got already a couple of different documents on the share folder here, and we can extract these parameters from available data, but obviously there will be different values when you are using different papers. So just to show you that what is the situation, I have already extracted some of these data on an Excel file here. So say this is the crack growth rate and this is delta K. So this data are coming from this paper, and now we have got the data here. I can just feed a line to this curve in order to calculate uh, C and M. So what we need to do, just insert a scatter graph, and then we need to make sure that we are using log scale for both of the axes here. So as you can see now we have got almost a straight line, and then if I add a trend line here, which will be a power, and I can ask for the equation. So then we have got our C and S values here. So what we have got is 5 times by 10 minus 8, just to make sure this is a little bit more accurate. So I can go here and format trend line label and change the category to scientific, and make it 3 decimal points or 4 decimal points, whatever you would like to say. Okay, so now we have got the values here. So now from here, C will be 5.177 times 10 minus 8. So this is a millimeter per cycle divided by megapascal square root of meter. And M will be 2.9044. So that is one C and M value you can use. For A and B, this is the table from the other paper, again available on that shared folder. Remember, when we talked about equations for A and B, we mentioned that the mean stress needs to be 0. But here we have got two numbers. First one is this one, where sigma m is 0.3 close enough to 0, and then another one here minus 0.3. So if I use these 2 points, I can calculate A and B from here, and again it will be just simply we have got two unknowns, and you can write down the equation of sigma equals to A times by NF power of B for two cases, sigma 1, sigma 2, N1, N2, and then solve for A and B. So this is the equation, and if you use these 2 points, we will get A as 624 and B as minus 0.068. I also added another paper here, the last one, fatigue and fracture properties. And this one also is for particularly 2122 T851. And they have looked at the C and M values for crack growth. So they are using a little bit of a different equation. So instead of C, they are calling this A, and instead of M, it is N. But here you have got log A and N. So M for us will be N, and C you need just to say 10 power of the whatever mentioned here in terms of log A. The advantage of this table is it has identified different C and M values for different ranges of delta K, as you can see from here. So you can use this C and M based on your application of the stress. And then for A and B, this is the SN curve. Again, I just digitize these points and use the best curve fit to calculate A and B, as I mentioned before. So this is the A value and this is the B value. Obviously, this A value is different from the A value we calculated from previous one. You can, if you wanted to be on the same experimental set, so I recommend using these A and B values as well as these C and M values. Let me know if you have any questions.